first one will be respiratory. Now, I think you guys know how to trace a breath of air. Wait, can you guys all do that at this point?
Yeah.
Or do you feel comfortable in trying to? Because if you do that, that'll help you a lot in figuring out what goes where and in what sequence. So let's go through it. Anybody want to try? One, ready? Okay.
I can do it.
You don't do that. Say it loud. Say it.
Sorry.
She's here.
External nerves to the nasal vestibular, then vestibular. No, it's the nasal concha. There's the inferior middle and or superior middle and inferior.
And what's the other name for that?
Something concha.
Huh?
I do not know.
Well, I don't want to. Louder?
The inferior middle.
What's the other name for the superior middle and inferior nasal concha? What's it called? What's it start with?
Yeah.
I can't do that on a phone.
But like.
Starts with a T. That didn't help? Terminator, not Terminator.
Terminator.
Terminates. If you want to remember Terminator, but it's the Terminates. Okay. Everybody up front, close as you get, grab a chair, bring over a chair. Too far away. All right. So Terminates. Now, what's after the Terminates?
Okay, and then it goes to nasal cavity.
What?
Nasal cavity.
Okay.
And then to the internal nerves.
Yep.
And then to the internal nerves, it's the, is it the nasopharynx?
Yes.
And then the oropharynx and the larynx.
What?
Larynx.
That's a hard one to say. Laryngopharynx.
Oh, so not even close.
So remember, when you look at the pharynx is named after the passage it goes. So it goes through the nasal cavity, so it's nasopharynx. It goes past the oral cavity, so it's the oral pharynx. It goes into the larynx, where the larynx is, so it's called larynx. So it's just nasal, oro, and larynx based on the anatomy as it's going through. Okay, you're now at the larynx.
Okay. And then I think it goes down to the triad.
What?
The triacha? Or I know how to spell it. I'm just forgetting how to
Go ahead and
say
spell it.
it. T-R-A-C.
Trachea?
Trachea. There we
Okay.
go.
Good.
So
But
close.
let's talk about the larynx for a minute. What's in the larynx? What are some of the structures you should know? Because it has to go through those structures to get to the trachea. So you've got the laryngopharynx, then it goes through a couple structures to get to the trachea. What are those structures? What's inside the voice box or the larynx?
I'm not sure. I know there's the glottis.
Yes. Right here. So it goes through the glottis, which is surrounded by say it louder? No. Vocal cords or folds. That's the vocal cords surround the glottis, and that's what gives you our sound. Now you can get in the trachea. Go ahead.
Okay, the trachea. And then the bronchioles or
Bronchi.
bronchi, and then the bronchioles, and it goes primary, secondary, and tertiary.
And then last three, after the tertiary bronchi, it goes to the small little,
Oh,
no, before it gets to the alveoli.
oh, I don't remember.
Elena, let's go back to Elena again. What are those three sections after the bronchi?
Primary,
Nope.
middle, second.
That's primary and secondary, tertiary bronchi. Then you go to those small sections. Starts with a B.
I don't know how to say it.
Bronchial.
Yeah.
Okay, so go. How many sections? Three? Tell me. What are they? No.
Is it
What are they?
Superior.
Don't read.
Okay, superior, middle, and inferior.
No. Savannah.
I got nothing for you.
What does it start with?
What? So you've got primary, secondary, and tertiary bronchi. Then you start bronchioles, but what are the three bronchioles?
I thought it was superior.
What?
It's not inferior.
No. You knew this last time I asked you. One thing easy, it starts with bronchioles, so what's the next section of bronchioles called?
A what?
Terminal.
Terminal bronchioles, and then, last one is respiratory bronchioles. Then you get to the alveoli. All right, now
So
it's
wait,
kind of
what
broken up. So I'm
Wait,
gonna-
so you said there's three or only two? Oh wait, there's three, so it's like the
So it goes
bronchial
primary,
right now.
secondary, tertiary.
bronchi,
Bronchi.
bronchiole, terminal bronchiole, respiratory bronchiole.
Bronchial, terminal.
So I'm gonna take you through the, what?
Can you just repeat that, like all of that
Yeah,
again?
I'm gonna do it. So I'm gonna take you, tracing a breath of air. So you start with the external, I'll go slow. External nares, nasal vestibule.
Nasal.
Am I going too fast?
Yes.
Sorry. You just need to shorten it. Nasal vestibule, superior, middle, and inferior nasal concha, or terminates. Nasal cavity, internal nares. Am I going too fast? Then you start with the three pharynxes. The nasopharynx, the oropharynx, laryngopharynx, larynx. Now there are cartilages in there, but you don't really need to know those because it's just there, they have different purposes. But you do need to list that the air has to go through the glottis surrounded by the vocal folds. Then the trachea. So glottis, vocal folds or cords. Then trachea. And this is where it splits at the carina, carina or carina, C-A-R-I-N-A, carina, into primary, secondary, and tertiary bronchi. Primary, secondary, and tertiary bronchi. That just means first, second, and third. And then bronchiole. Terminal bronchiole. Respiratory bronchiole. Alveoli.
How do you like tell the difference between the terminal and the respiratory bronchioles? Because I'm looking at a picture and they look very similar.
The one right before the alveoli is the respiratory. The one right before the respiratory is the terminal,
Okay.
right after the bronchiole. It's really about sequence. That's the only way you can tell. They're about the same size and shape, so.
Would you say this is right? They're both ones.
So that- Perfect.
Wait, so what are the three for the bronchial? It's respiratory, terminal, and bronchioles.
It starts with bronchiole, after the tertiary bronchi,
Yeah, I
bronchiole,
just said it so slightly.
terminal bronchiole.
Is that
Then
the
respiratory
tracing, like,
Okay.
edge
Yeah.
of the-
Which doesn't make
Yeah.
sense because you'd assume terminal would be the last one, but it's not.
Thank you so much.
Let me just send it to you.
The alveoli?
Yeah, where is that exactly? Because when I
So-
look at pictures, I don't see it.
This just shows you the location, but if you scan down to that, that shows you the inside. All you have to remember about the alveoli is that the red vascular structure is the vein, pulmonary veins, and the blue vascular structure is the pulmonary arteries. And that's where the gas exchange takes place. And it's based on concentration gradients. You ever understand a concentration gradient? I think I explained it. Did I explain?
I just sent it.
Thank you.
No, yes, good. Savannah, can you explain it to me?
Oh.
You got it?
Yeah, I got what you said.
Concentration gradient? Do you understand that?
Yeah.
Nia, do you understand?
Concentration grade? Grade? Trade grade.
I remember this was one of the questions on the homework assignment, but I feel like I did not learn it enough.
So you want me to explain real briefly what concentration gradient is? Okay. It's really, if you look at it basically, it is high concentrations of any product will always equilibrate, balance with low concentrations of a different product. I'll say that again. So high concentrations of any item, let's say sodium, will always equilibrate, which means it'll balance out on the other side of the membrane with the other product of low concentration. So higher always flows to low until it equilibrates, until it actually balances. So if on one side of the membrane you have high sodium water, on the other side you don't. The sodium will leak to the low concentrated side until it equalizes. That's all the concentration gradient is. It's a form of equalization.
So in the concentration gradient for like the alveoli, is the high concentration carbon dioxide? Or-
Right. So in that situation, we're talking about high concentrations of CO2 coming back from the pulmonary arteries into the alveoli, but low CO2 concentrations in the lung. So they're going to basically leach out of the capillaries into the lungs and breathe out. At the same time, you have low oxygen levels because they've all been used up by the tissues on the inside. But when you're breathing in, you have very high concentrations of oxygen in the alveoli that'll leach into the capillaries, into the blood, and be taken back.
So it's low oxygen in the blood, or
Say it again?
where's the low oxygen? I
The
guess-
low oxygen is going to be in the actual capillaries. In this case, going to be pulmonary arteries or pulmonary capillaries that are going to be taking in high concentrations of oxygen from breathing. This is high concentration of the air. You take a breath in, it saturates the alveoli, it filters into the capillary bed, into the blood, and then it takes it back to the tissues. Just a matter of balance. Okay, everybody got that? What else you have to know about respiratory? What about the actual lung itself? You have two lungs, right and left. How many lobes in the right lung? 3, 2 in the left, because the left has a cardiac notch that the heart sits in. And those lobes are separated by fissures. The right has a longitudinal fissure, which means it goes horizontal. And the other, and it has an oblique fissure, which separates the 3 lobes. The left has just a oblique, which separates the 2 lobes.
I had listed that the right lung was horizontal and oblique. Is that okay, or should I put longitudinal?
Say it a little louder.
On the right lung, I have horizontal and oblique. Should I change it to longitudinal?
So they have horizontal instead of longitudinal?
Yeah.
Good, that's fine. Horizontal's good. Horizontal oblique on the right? Okay.
Wait, and then the left has the which one?
Say it again.
Which fissure does the left one have?
Which fissure does the left lung have? Yeah? Oblique.
The right has.
Longitudinal and oblique.
There's 3 major muscles of respiration. The major one you already know is what? Diaphragm. But the 2 other ones are smaller. They're called internal and external intercostals. One actually elevates, the other one compresses. But those are the 3 major ventilating muscles. Okay.
Which
Say it
one?
again.
It's the internal and external.
Intercostals, meaning the muscles in between the ribs.
Which one is the one that elevates? Which one is the one that like depresses?
Say that again.
Which, like the internal and external, which one is the one that like?
External will compress, internal will expand. All right. What else do we have to know anatomically? Let's go. You should know a little bit about the larynx itself, the different cartilages. So you have the anterior cartilage of the larynx, large one is called the thyroid. The posterior largest cartilage is going to be the cricoid. Inside the voice box, you'll find a arytenoid. That's an interesting word. But right here is the glottis, which is the open area surrounded by the vocal folds or the vocal cords. They both are basically the same. But this shows you also the incomplete rings of the trachea Make sure you understand why the ring is incomplete in the trachea. Anybody like to explain why they're incomplete? No volunteers? Oh.
Does it
Say it loud.
maintain airway patenance and prevents collapse under negative pressure during inhalation?
Right. So when you swallow, your food, the esophagus is kind of a closed tube. When food hits it, it drops through the laryngeal pharynx into the actual esophagus. It actually begins to dilate. So the esophagus, which is a small tube, dilates as the food goes down, pressing in on the trachea because the esophagus goes right behind it. And so if it was ringed all the way across, the food would get stuck. So it's not. So it allows it to press in without harming the trachea or catching any problem with the food. All right. Let's see. Anything else in your notes, Mia, that I'm missing? Make sure you understand that the left primary bronchi is more narrow and longer because of the heart, and the right is thicker but shorter. This kind of shows you the right and left lungs we talked about. This is called the hilum or helix. If you're getting any questions at all about the hilum or the helix itself in the lung, it's basically one concentrated area on the medial aspect of both lungs, where all structures go in and out. A helix or hilum is a closed area where everything's going into one structure and coming out. So all the arteries and veins, bronchi and lymph and everything else goes through one concentrated area. And remember, the lung is it's not a balloon. It's actually a solid structure full of alveoli. It has many, many hundreds of millions of alveoli through the lung itself. So if you were to cut into the lung, you would have air come out, but it isn't like a balloon that would deflate completely. Only that one section that the alveoli was affected. If you ever looked at lungs like a cadaver lung, well, you kind of, if you remember, the cadaver lung was solid. All the alveoli had collapsed, and that's why it made it so small. I don't think we have any questions on this. There is a term you may want to remember. It's called surfactant. And surfactant is a substance that is basically created from type 2 pneumocytes. A pneumocyte is just a lung cell. Pneumo is lung, cyte is cell. So a cell in the lung is called a pneumocyte. A type 2 secretes surfactant. So what does surfactant do? It prevents alveolar collapse. How does it prevent an alveolar collapse? Well, alveoli are these little grape clusters, all right, and they're usually full of air. Because you're breathing in and out, there's always some kind of resistance in there to hold the grape cluster, a hollow one, open. As you get older, these particular little grape clusters, if you don't exercise or if you are in rigid or frigid environments where there's a lot of cold, they actually begin to start breaking down and they can start collapsing. The surfactant is a mucus that surrounds all that and keeps it supple so they're not constantly collapsing in cold air or too much exercise or whatever. Surfactant basically preserves your alveoli, keeps them the ability to open and close with the air coming in and out. Everybody clear on the anatomy of the pulmonary circuit, arteries and veins? Everybody know what arteries and veins are in the pulmonary circuit? Molly?
What?
So for the class, clarify the difference between an artery and a vein in the pulmonary system.
Arteries are deoxygenated in the pulmonary system and veins are oxygenated.
Why?
I don't know, but it's different from the rest of the body.
It is.
I'm guessing because it's getting oxygen in the lungs.
Okay. So what is the definition of an artery?
It takes blood from the heart to the rest of the body.
So it's taking blood from the heart out, away from the heart. Anything, any vessel that takes it away from the heart is gonna be an artery. So how does that pertain? How can that be with the pulmonary circuit? Explain to me the pulmonary circuit. You remember?
No.
Anybody remember?
It's, the heart is pushing out deoxygenated blood from the right side of the heart, and then it goes to the lungs, and then gets oxygen.
Okay, stop. So it's pumping from the right ventricle through the pulmonary valve to the pulmonary circuit, or truck out to the lungs, which means it hasn't been to the lungs yet. That's why it's blue. That's why it's, you're right, deoxygenated. But it's called an artery only because it's going away from the heart, even though it's not oxygenated, because it hasn't been to the lungs yet. Okay, does that make sense? But now it goes to the lungs and it comes back to the heart. So anything that goes back to the heart is a vein, no matter what its contents is. So even though it's oxygenated, it's a vein until it gets into the systemic system and it reverts back to an artery. Okay. Please remember that you guys will definitely be asked that. I do want to remind you that the lung itself is covered in what we call a pleural membrane. A pleural membrane, don't worry about visceral or parietal, but that the actual lung sits in a membranous sac we call the pleural membrane. It protects it, just like the heart has covered in the pericardial sac with a pericardium on it. And it has serous fluid around it, so the constant beating doesn't traumatize the blood vessels or anything around. The lungs are just the same. They're encased in a serous fluid that every time you take a deep breath in and out, it's not going to damage the ribs or damage the heart by actually breathing into it. So this is called the pleural cavity. And if you get an infection in there, you can get pleurisy, which is just the inflammation of the pleural cavity. This is actually quite common, surprisingly, but the pleural fluid, that serous fluid in the pleural cavity, reduces the friction when the lungs move, because your lungs, hopefully, are constantly moving. And so they're traumatized, just like your heart is constantly moving. So the heart and the lungs are surrounded by cavities full of fluid to help it from traumatizing. You already know about those two muscles. Oh, you do have to know a couple terms. You may see this term, eupnea. So it's called eupnea. This is when you're having quiet, relaxed breathing. Just normal, calm, relaxed breathing. Hyperpnea is when you're doing forced breathing or deep breathing, like exercise, running hard, or doing yoga where you're doing cleansing breaths. Anybody ever do yoga? Okay. In yoga, they have a cleansing breath process, and that's what hyperpnea is. Is you take 2 minutes, lots of air in, and then you slowly blow it all the way out. So, or when you're exercising. So, hyperpnea and eupnea. Eupnea is when you're relaxed, quiet, and just melt. Hyperpnea is when you're exercising or doing deep breathing. One last thing, just in case it comes up. There are a couple of centers in the brain stem that control breathing. Generally going to be in the pons or the medulla, depending. So you have the respiratory rhythmicity, great word. What is rhythmicity? What do you think? Any ideas?
Rhythm?
Yeah. It just means this is the actual rhythm of your breathing under normal circumstances. This is a center, a neurological center in the brainstem that sets your normal breathing rate when you're not exercising. It's anywhere usually between 12 to 16 breaths a minute. This is actually there to help protect you from either rapid breathing or not breathing enough. Then there are two other centers. You have an apnoistic center that is constantly adjusting the respiratory center or the respiratory pace. Apnoistic, when you put an A in front of a word, it means without. So this is without breathing center. That means this one stops you from not breathing. And this one, pneumotaxic center, adjusts the same thing, but it protects you from over inhalation. Your lungs have the capacity to actually explode in your chest if you constantly were breathing in and taking more air in. They would actually extend to the point where they would just explode. So you have centers that help them make sure that you breathe enough, but you don't breathe too deep and cause damage to the lungs. Okay? So this is the actual center, which is controlled by these two nuclei. Apnoistic controls making sure you're breathing enough. Pneumotaxic controls it, make sure you don't over inhale, over inflate the lungs. Question, Bob?
So those are all in the pons and the medulla oblongata?
Yeah, so they're located, here's the pons, and you have the pneumotaxic, apnoistic, okay? And then you have the respiratory rhythm centers, which are basically located down here in the medulla. So this is what actually regulates or sets the breathing rate. These are the ones that control that breathing rate. So since you may get a stimulation when you exercise to breathe faster, or when you're sleeping to breathe slower, or if you have sleep apnea, to stop breathing completely. The interesting thing with sleep, you know anybody with sleep apnea? You've heard that term? Okay. So sleep apnea is basically when you're at night usually, you're breathing and you're breathing, it's called cessation of breathing. It happens and you may not breathe at all for 5, 6, 7 seconds. If it's really bad, it may go to 10 to 12 to 15 seconds. And then you rest and you breathe again, and that cycle goes on until you have another one. The problem with that is that you will eventually start creating hypoxia to the brain. So these centers help control that most of the time. I think that's about, we don't have to worry about too much. Okay, let's jump on here real quick. Digestive is a little bit different. Who wants to do the digestive tract? I'm going to pick up the hand. So again, the best way to remember all the anatomical structures is to take it through hanging. So the digestive tract, as we know, starts in the oral cavity. You could say lips, but that's more of an ancillary. In the oral cavity, digestion begins because you have mechanical and you have chemical. What's the mechanical and what's the chemical digestion process? Chewing, mastication. Right, so you have 3 salivary glands on each side. They secrete digestive enzymes. Mostly it's going to be something called amylase, and amylase helps break down carbs. But you also have to chew the food, okay? That's where your tongue and your teeth come in for mechanical digestion. That's happening in the oral cavity. So you've got, the oral cavity is composed of lips that bring the food in, salivary glands that break it down chemically, teeth and the tongue that manipulate the food to make it presentable. The tongue lifts it up and pushes it back into the pharynx. What pharynx is it going to go into? What's the pharynx right behind the oral cavity called?
I want to say oropharynx.
Oropharynx. So the food goes into the oropharynx and jumps down as it heads toward the esophagus. What directs it to the esophagus? Amaria? What? Say it again. Oh, sure. what directs, after it's in the esophagus, after it's at the back of the mouth, what directs it to the esophagus so you can swallow it down? It's part of the respiratory system. Yes, it does, very good. EPI. Close enough. What's it called?
Epiglottis.
So the epiglottis, because you have the trachea on the anterior, and right behind it is the esophagus. So the trachea has an epiglottis. When you put food or liquid back there, it closes the trachea and the food slides nicely into the esophagus. The esophagus is a muscular tube that actually causes peristalsis to send it down into what part of the stomach? What's the first part of the stomach? It's actually the esophageal pharyngeal portion, but they call it the cardia. Okay? And next to the cardia is the top part of the stomach where all the gas goes, the swallows. That's called what? Starts with F. It's a lot of fun. The fundus. All right, then you go into the body, and you drop down into the actual pyloric area. So what is in the stomach we need to remember? So what are those folds that allow distension and contraction? What are those called?
Is
What's
it the rugae?
Rugae. You gotta roll your R's.
Okay.
Rugae. So rugae are the folds inside there. On one side of the stomach you have a greater curvature. On the other side you have a lesser curvature. And the stomach is unusual because it has 3 muscle layers. The only area in the entire digestive tract that has a 3rd layer. What are those 3 layers? Lexi?
Longitudinal, oblique, and circular.
Circular, longitudinal, and oblique. What's the extra layer? Anyway, what's the extra layer? Mia, you know this. What's the extra layer of muscles in the stomach? You have longitudinal, circular, and oblique. Which one's extra? Yes. It has an oblique layer, which is nowhere else in the gastrointestinal tract do you find that, because the stomach does the same thing as the oral cavity does. It does chemical digestion, but it does mechanical digestion by churning and twisting, and that's what the oblique muscle allows. So the oral cavity and the stomach follow the same pattern. So now we're in the stomach. Who wants to take me the rest of the way? Jenna, you want to jump into that first part of the small intestine? No? Judith?
So it's the duodenum?
Duodenum. You can pronounce it either way.
Okay.
Next one, Elena? The JJ. It's a hard one. If you think of jujitsu, which is a martial art, it's jujitsu. After the jujitsu. Starts with an I, Ellen? Ilium, close enough. So you have the duodenum or duodenum, the jejunum, and the ileum. That's your small intestine. What happens in the small intestine? Mostly for nutrient absorption. How does the small intestine connect to the colon? You guys remember? Yes.
The ileocecal
Ileum.
valve?
Ileum does what?
The ileocecal valve? Like-
Ileocecal valve? Is that what you were trying to say?
Yeah,
Yeah.
okay.
It's called the ileocecal valve because it comes from the ileum to the cecum, which is the first part of the ascending colon. And what is the structure that comes off of the ascending colon? Starts with an A, has a couple P's. Has an X at the end?
Appendix?
Thank you. So appendix. And why is the appendix there? Because the appendix is a lymphatic structure full of lymphocytes, and it basically protects the bacteria buildup in the cecum before it goes through on that whole process. So now we're in the large intestine, or the colon. We start with the cecum, and you go through the ascending colon to the transverse colon, actually ascending colon, transverse colon, descending colon, and you end with the sigmoid, which means S-shaped, sigmoid colon, down to the rectum. Okay? So what do you have to know about the colon? Say it again?
The hostra,
So the hostra, what are the hostra?
the little muscle.
Little pouches. So your colon is actually made up of these little pouches, that's why they call it hostra, which means little house. These little pouches all the way across, and they're held together in the front and back by this little muscular structure that ties them together called what?
Tinea coli.
Ladder.
Tinea coli.
Tinea coli, exactly. Excellent. All right. Now, what is the difference between segmentation and peristalsis? Any volunteers? Or do I get to choose me again? No volunteers. Yes.
So segmentation, like break it up, and then peristalsis just like pushes it like down the tube.
Essentially, that's exactly what happened. Peristalsis is a contraction that moves the bolus of food down the tube. Segmentation is that it doesn't move anywhere, but basically it pulverizes it, makes it smaller and smaller and smaller. So it's easier to digest and absorb. Good. All right. Let's see. This is actually a pretty good chart to study from. All the different absorptions and ancillary. So we have ancillary digestive structures, or organs. So we know that the liver produces what? Bile. The gallbladder does what? Stores the bile. And the pancreas is the only organ in the entire body that has a dual function. What is its dual function?
Enzymes and hormones.
That's right. It's part of the endocrine system and it's part of the digestive system. For the endocrine, it secretes what two hormones? Anybody? Insulin and, it sounds like glycogen, but it's glucagon, which helps break down glycogen. But the digestive component are the enzymes, proteases, carbohydrases, lipases, and nucleic acids. That's what breaks down all the actual nutrients for absorption. All right. Actually, there's one other area I want to talk about. This is the 4 layers. You probably will have a question about this. Now, you're not going to have this diagram, but you may have a question about the 4 layers in the digestive tract. And other than a couple of very specific areas, they follow the same pattern. Internally to externally. Internally, you have the mucosa. That's where all of the actual digestion takes place. Then you have the submucosa. Then you have the muscularis. And then you have the serosa. I think we can actually take a different view look at this. We go over here. Maybe. No. Let's look at the oral cavity real quick. Don't forget the oral cavity. You do have tonsils. Are the tonsils part of the respiratory system or digestion?
Part of the lymphatic system.
What's right?
Lymphatic system.
What do the tonsils do? Or could the tonsils be part of another system?
Help prevent infection.
Which makes them what, part of what system?
Lymphatic.
Is that what Lexi said? Yes. Even though they're located in the respiratory and the digestive area, they're part of the lymphatic system because they're full of lymphocytes to help reduce the amount of exposure that the digestive system and the respiratory system gets. Salivary glands, you guys know all this. So please remember this: parotid are the large ones on the mandible, and the other ones are submandibular and sublingual. Those 3. No teeth. No swallowing. Right in the stomach. Mucus cells, not really that. There may be a question on this, so I'll show you about this. Inside the actual mucosa of the microvilli are something called a lacteal. And lacteal is part of the lymphatic system. So here you see the actual nerve in yellow, artery in red, the vein in blue, but this is your lymphatic system. And the lacteal goes right up through the center of these villi that come up and line the gastrointestinal tract, mostly small and large intestine. They're there to absorb lipids specifically. And they take those lipids into the lymphatic system, purify them, clean them up, and then put them into the blood system. Lacteal. Okay, I think we're good on that. Everybody know what emulsification means? Emulsification is basically not just breaking down fats, but disarticulating fats into other products, like glycerides and other things. There's probably one more thing you have to remember, and that is the hepatic. There's something called the hepatic portal system. And the hepatic portal system is, hepatic means what? What organ? Liver. So the hepatic portal system is a blood flow system. We know that the liver, it has about 500 different functions, but the main function, it does produce bile. But the liver also has a tendency to have these large portal areas of arteries, veins, and lymphatic tissue come in, and the liver acts as a detoxicant, and it restructures RBCs that are broken down and eliminates damage to different cells before it dumps it back into the inferior vena cava and then takes it back to the heart. So all the blood from your visceral area comes into this hepatic portal system, goes through a cleansing mechanism and a kind of a restructuring mechanism, dumps it back in the inferior vena cava and takes it back over the heart, and now you have kind of a renewed blood flow going back from the heart. We haven't talked about that much, but that's literally called the hepatic portal system. It's more of a detoxification, restructuring mechanism for the blood through the liver. I think we're good with that. Yeah, pancreas, we have one more thing. You may see this, acinar cells and pancreatic islets. So remember we said that the pancreas is a dual organ, has hormones and have digestive enzymes. So the hormones come from the pancreatic islets in the pancreas, and then the actual digestive enzymes come from the acinar cells. So that's it. If you can remember where those come from. So where does the hormone come from? From the pancreatic islets. Where do the digestive enzymes come from? It comes from the actual acinar cells inside the pancreas. That would be the origin. Everybody got it? Okay, we're done. We went on. Only two more, so only 4 o'clock. Now we need a little more difficult. Volunteers? Trace a drop of urine from the renal corpuscle of a cortical or juxtamedullary nephron. Anybody want to volunteer? Okay, I'm going to take you through it once, and now I'm going to ask somebody to do it again. So, we know that the cortical nephrons are the functional unit in the urinary system. Their purpose is to filter the blood of what it doesn't need and then to excrete it out. So it starts with an afferent arteriole coming into the glomulus inside the renal corpuscle. Let me make this a little easier. So it starts with the afferent arteriole. And by the way, you have hundreds of thousands of these nephrons in every one of those pyramids. So blood, all blood in the body will go through nephrons. So afferent brings it into this, which is called the renal corpuscle, goes through a capillary bed called the glomulus, and then out through the efferent arteriole. No veins, strictly arterial structures, only oxygenated tissue. Let me show you real quick what that looks like. So that's what the glomeralis looks like on the inside. It's just a capillary bed. The purpose of the renal corpuscle, sometimes called the Bowman's capsule, is to basically leach out inorganic wastes or ions that the body doesn't need, or broken down tissue or whatever. And it takes this, called a filtrate, maybe 3 to 4% of the total blood flow will come out, and it goes into the tubular system. So let's go back. Tubular system is now the filtration system. So as it goes through the PCT, descending loop of the nephron, DCT, and dumps it into the collecting duct, all through here, that filtrate is being absorbed. It's being reabsorbed or secreted or changed depending on the needs of the body. So what actually ends up going in here is urea, which eventually, as it goes through the collecting duct, turns into urine. But through here, lots of reabsorption takes place of ions, of water if need be, under the influence of what hormone? We know this. What hormone reabsorbs water back into the system, especially when you're dehydrated?
Antidiuretic.
Antidiuretic hormone, ADH, coming from the anterior pituitary. Very good. So afferent glomeralis, renal corpuscle, PCT, descending loop, ascending loop, DCT, distal convoluted tubule, into the collecting duct, from the collecting duct down to the renal papilla, and from there, we have to switch over to the actual cartilaginous tube, which would be, here's the renal papilla, there's your actual, well, your nephrons will be up here. The collecting ducts all come down here. So they go into a minor calyx, to a major calyx, to the renal pelvis, to the ureters. Now, somebody should be able to take that all the way out. And Marina, you can do this. Ureters, go to what structure next? Urinary bladder. And how does the urine get from the urinary bladder to the outside?
Wait, what?
How does the fluid in the urinary bladder get to the outside?
It
Through
goes
what?
to the urethra.
Goes through the urethra. Now, if you have a male urethra, what are those 3 sections? Anybody remember?
I know one.
What's the first section? What does the male have that a female doesn't have? What organ? So that's prostatic urethra. What's next? Small little area called membranous urethra, and the last part?
Spongy.
Spongy urethra. So prostatic, membranous, spongy urethra. Okay. So that's how you trace the duct line. We do it one more time without stopping. Afferent arteriole, glomeralis, efferent arteriole, renal corpuscle, PCT, descending loop, ascending loop of nephron, PCT, collecting duct, renal papilla.
You said wrong.
Pardon?
You said PCT. You said
PCT first, DCT, did I mix those up? Okay. PCT, proximal is always close, DCT is always further away. Then you have the collecting duct, renal papilla, minor, major calyx, renal pelvis, ureter, bladder, prostatic urethra, membranous urethra, and urethra. Boom, that's it. Now, in addition to that, you guys have to know the other areas. When you look at this, let's move over here because it shows it a little bit better. So you have a renal capsule, when you look at the kidney, renal capsule, this is the actual cortical renal cortex. This is a renal medulla made up of renal pyramids. So don't forget those sections as well. Okay? You want to try?
No.
Good. You already answered that one, so you do good. I think it's time for Jenna to jump in here. You can do this. So, where does it all start? What's that little thing with the glomulars? Say it again? What's she saying?
The nephrons.
Well, yeah, that whole nephron, that's where it all starts. What's the first part of the nephron? Has a glomularis on the inside with an afferent and efferent arteriole coming into it. What do we call it? Renal what? Renal C? Well, that is a right answer for another question. The renal capsule is going to be this outside layer. Okay? So what are the other things? What is a PCT? What's what about the nephron loop?
DCT, descending, ascending, BCT.
There you go. You say the other- Yeah, I took it as the opposite. All right, Lexi, take me through it real quick.
I'm still learning.
Wait, could you explain that again?
So is that like, that's the kidney, right?
What's that? Oh.
That's the kidney?
I don't know.
That's a kidney?
Please
What is
correct
this?
it. I don't know. I don't know if it's right.
Same thing as that.
I don't know if it's right.
Can I
Yeah,
try?
so does the kidney. He was going really fast.
Is that like how you
So-
spell coffee?
So making sure. No, I don't know.
Yeah.
Just checking.
So, this is the renal capsule on the outside, the renal cortex. The renal medulla is a layer made up of renal pyramids. Okay? So that's one area. But then when we get to Jenna's question, we have to start at the nephron, which she identified correctly, at the very beginning, and trace that all the way through. Okay? You good?
No. How do
Go
you
ahead.
spell globularis? Can you spell that?
Say it again?
Globularis or
So,
globularis, what do you spell that?
oh, globule, thank you.
What? I can't.
You're going fast.
G-L.
O,
Oh.
E,
I'm confused.
U.
You said the medulla is like, is it on top of the pyramids? I'm confused.
The pyramids make up the layer called medulla.
Oh, okay.
So, like this layer is the outside layer of the entire kidney called cortex. And this layer of pyramids
Sorry.
makes up
I can't tell if this is correct or not. I tried to write down the best I could, but I think it's wrong.
you want us, it's not,
I
it's not
can't tell.
lymph, I don't know.
Because you showed us power
Glomulars.
to live
Hold
power
on.
plant.
That's good, but make sure you put down glomulars.
How do you spell that?
She'll tell you.
Is it with a B or an N?
Glomularis, G-L-O-M.
M-E.
It's with an N.
Oh,
E-R.
Glomularis, no, G-L-U-M, glom,
So what?
G-L-O-M-U-R-E-L-E-S.
What? Wait, what?
Go ahead.
Okay,
So nobody's close.
G-L-O-M-E-R-U-L-U-S.
Got a couple L's in.
Glom.
Okay, I'm just gonna. Just guess.
Just take off. Yeah, that's close. Take off R. Yeah.
He'll take it.
Close enough.
Whatever.
Is that a correct order though?
I was
Yes.
Okay, so
Is
everyone
that an
is
image we need
correct
to
then.
know for the test?
No, we covered all that.
Wait, so
So
this
you're
is-
there, you're good, what?
Are you gonna show us after us all the images that we need to study?
Just talking with your hand. in-
Sorry, are you gonna show us after like all the images we need to study?
Am I gonna add?
Are you gonna show us like all the images that we need to study?
I thought I already did that.
Well,
Yeah,
yeah, but
you
now
showed
I'm
us all
confused.
PAL.
PAL too, so now I'm confused.
Okay, there will be no PAL.
Okay.
No PAL
Okay, but I
picture.
don't get specific
Which ones?
ones. Yeah,
So
which
which
ones?
ones are you?
There's so many pictures, like,
Yeah, I'll take you through that one more time. We have to get through reproduction.
okay.
I'm just
We put a
You know, because we're doing this, I'm gonna expect every one of you to get an A on this test.
No.
You're funny. Yeah, no. I have an
Wait,
A. I need an A on the phone.
sorry,
I need
can we one more time?
Yeah.
It's the N word.
to even have an A.
Alright. So So this, again, we have to trace.
I know what you mean. We don't have anything to trace for this. I know. Right, you might be talking. That was my grade.
So trace, where do we trace? For male, we trace from the testes, and female ovaries. So basically, you start with the seminiferous tubules inside the testes.
Oh. What? I read something toothpaste. Oh, go.
Seminiferous tubules.
Oh, there you go.
So the seminiferous tubules, that's where the testosterone converts nurse cells and stem cells to spermatocyte cells. We call them spermatozonia. But this is where the sperm cells are produced, and they go through this process of production. Then they go into the retinitesty and up into the epididymis for maturing. And from the epididymis, I'm going to go back again.
Can you leave that? Wait, can you go back and leave that up for like 2 seconds?
So now, that's where all the seminiferous, they come up the epididymis, they go through this for maturation process, and they go into the ductus deferens or the vas deferens. That's a passageway. It takes all the way around, hooks around the actual ureter, and goes to the seminal vesicle. At the seminal vesicle, they pick up their first, talk about sperm like they're my friends. Anyway, so the spermatocytes pick up the semen first at the seminal vesicle, then they pick it up at the prostate, and then they pick it up at the membranous structure. And they basically come out through the prostatic, the membranous, and spongy urethra. So when you learn the urethra in urinary, it's the same obvious structure that you're learning in reproductive. That's the pathway, okay?
What's that
Now, there's
pathway
other
for?
structures you need to know. So you go seminal vesicle, ejaculatory duct, prostatic urethra, membranous urethra, spongy urethra. So Anna,
What's that pathway for?
which one?
What's the pathway for?
That's for the sperm and the semen to exit
Okay.
upon
Oh,
ejaculation.
sperm penetrates.
Yes. Okay.
Go over it again.
Now, if you look at it anatomically, the testes sit inside a scrotum, which has a double layer. There's a muscle in there called a dartus muscle and a cremaster muscle. How many girls give me that look? What? What are you talking about? Okay, let me go find it. So here's the, nope. There we go. So here's the dartus muscle and the cremaster muscle. That's how you spell it.
Okay.
Okay. So the scrotum, the sac that the testes sit in, is actually controlled by the dartus muscle. But the actual structures in the walls are called cremaster muscles, and that's what can pull up the testes when it gets too cold. Get it closer to the body to maintain some kind of warmth. Not going to worry about the vascular structures at this time or those areas. Just remember that spermatogenesis just means the production of a sperm cell, and meiosis is the production of sex cells. And those are the Christmas tree lights. You guys remember those? Okay. Sperm itself, well, here's how they break it down here: head, middle piece, and tail. Remember that it is a tail that rotates, not swims. And the body is full of mitochondria. The head has a genetic material, and an acrosomal cap covers it, full of digestive enzymes to burrow its way through the wall of the ovum.
Wait, what'd you say the meiosis was?
Say it again?
Meiosis? Meiosis? Wait, what'd you say it was?
What did I say?
A
What was?
reduction of the.
Can I have a complete sentence?
It's okay, she just answered it.
Okay, then. Thank you. You guys can answer, please do. So this is called a spermatozoon, which is a young spermatocyte. It will mature as it goes through the epididymis and so on and so forth. Okay. You guys got all that already? And that. Yes. The other thing you have to know is corpora cavernosa and spongiosa. That's basically what makes up most of the structure. Around the spongy urethrum, you're gonna find the actual corpus spongiosum, which would make sense. The spongy cavernosum is actually making up the outside, and then the glans penis is special erectile tissue covered in a prepuce or foreskin. Erection occurs because the deep arteries actually vasodilate under the influence of the parasympathetic system, not the sympathetic system. And there you go. Now we get into the hard one. So this one we start with ovaries. The main function of ovary is to ovulate, to release an egg that is caught by the fimbria, taken up into the ampulla of the uterine tube, and waits. The ovary is connected by ligaments and held by an entire broad ligament that covers everything. The uterus has a perimetrium on the outside, endometrium on the inside, but the majority of the wall is myometrium, mostly muscle. The front is called the cervix with an opening called the external nos, and then the vaginal canal takes it out to the external. External genitalia are the labium minora and clitoris is similar to the glans penis. Everything else is about the same. The only thing it doesn't show is a hymen, which we already talked about. So there's two types of cycles women experience, uterine and ovarian. So the ovarian cycle, which is oogenesis, which means the production of oocyte. I'm not stuttering, that's how they pronounce it. So the female gamete is going to be an oocyte. The male gamete is going to be a spermatocyte. When they actually form individually, they're a gamete. What are they called when they actually fertilize and come together? It's a zygote. It's a single-celled structure having both genetic material from both contributors. So you have about 2 million primary oocytes, but at puberty you only have about 400,000 left, which means you lose 1.6 million oocytes during your youth and your young adult life. Let's see. Ovulation basically is the releasing of the oocyte, or the gamete release. If you want to know, probably you may not be asked this because we're not talking about the endocrine system, but when you have a rise in luteinizing hormone, it causes the follicular wall or the actual oocyte wall to be thinner, which allows it to be ovulation to occur. Progesterone is basically what is being used to prepare the uterus for pregnancy. If that does not happen, then everything decomposes and everything sloughs off. Pretty much we already covered all that. So remember, the uterine cycle is basically, you refer to it as menses. It is the proliferation of the endometrium, preparation for pregnancy. If that doesn't happen, then there is a decomposition under the influence of progesterone, and it basically sloughs off. Proliferated is the increasing, secretory is getting ready, and if there's no implantation, then menses occurs. I think that's about it.
Could we go through the sperm tracing for the females again?
Say one more time.
The sperm tracing for the females one more time?
The sperm one?
Or not sperm, the egg.
The egg?
Yeah.
Tracing.
Where? Okay.
Like tracing.
Ovulation?
Yeah.
From what point? From the beginning?
Yeah.
Okay. So urine is basically preparation for pregnancy implantation. That is how the menses occur. Well, the oocyte, or the ovarian cycle, is when you actually, if the egg under the influence of progesterone and estrogen and a couple other hormones actually goes through a mature state from a single all the way to what's called a Graafian follicle, which means it matures just like the spermatocyte does inside the ovary over a process. Usually the process begins as soon as menses is over, and it doesn't occur again until ovulation cycle begins, usually anywhere from 24 to 28, sometimes 30 days. It varies. That whole process, though, is developing a mature oocyte to be released into the fimbria, to be taken up into the ampulla, and it stays there waiting for the spermatocyte to get there. Does that make sense? Sort of.
Kind of. So what exactly do you want us writing down for like the tracing?
Anatomy.
Say it again.
Like I'm
Louder.
Anatomy.
Oh, you want the anatomy?
Yeah, like tracing the egg.
Okay. Let me take you to let's go back here. There it is. So this is what's happening inside the ovary. She asked, I'm only gonna.
Take it away.
So basically, in those 28 days of preparation up to ovulation, you have what they call constantly. You have these kind of an egg nest, a promoidal follicles, egg nest area that is existing, and under the influence of hormones, they go through these cycles of developing a follicle, then a secondary follicle, then a tertiary follicle, until they get to what's called a Graafian follicle. At that point is toward the end of those 28 days, and that's when the walls of the ovary begin to thin, and the pressure and the release of the oocyte takes place into the fimbria, which takes it up to the ampulla of the uterine tube and stays there. This is the painful time. Okay. Anything that breaks open in your body is usually not comfortable.
So we're gonna have to like trace like a sperm, but like, do we also need to trace an egg, like starting at the ovary and then like into the fimbria and everything like that?
No, because you're only talking about an inch travel.
Okay.
So it's not that it's not important, but it's not testable.
So what's the oocyte? Is that just the egg?
Yes.
And then there's the oogenesis.
Oogenesis is the production of those eggs. That whole process is called oogenesis.
Oh,
Wait, so oogenesis production?
Yes.
and then the egg is called oocyte.
Oocyte. Yeah. So it's oogenesis, and what it produces is the oocyte.
Okay.
I'm just gonna delete
What?
this whole woman section.
Ovarian is the ovary itself. That's the ovarian cycle.
Delete all of you. I will ask you.
That's the cycle that starts at day 1, goes for anywhere from 24 to 28 days before you actually have a release. Because it'll die. If it's not impregnant, I shouldn't say impregnant, if it's not fertilized within 24 to 48 hours,
It's
it usually will die.
die.
Die?
You won't die.
Oh.
Your egg will die. In other words, if you're on a 28-day cycle, the chances of you getting pregnant are pretty slim.
Oh, fine.
However, don't take that for granted.
Oh, yes.
That's like what it is.
What?
Nothing.
So, like, what happens when a woman is like struggling with infertility? Is it just like she's not releasing like an egg, or?
What it does is it mass produces. So she'll have, there's a possibility that she could produce 2 or 3 of these in a cycle. Not only that, is that, well, you have to remember when you're doing that kind of therapy, you're literally having sex pretty much all the time.
Okay, yeah, but like.
Because this still happens, it's still uncomfortable, but there's only, again, even under those circumstances, if you ever talk to people that are trying to have a baby and they're paying for all this money with hormone therapy and all that, they've got it dialed down to when she's ready and when she's not, and there's like a 48-hour period, maybe 72 at the most. That's when they'll go crazy.
No, but I'm saying that like they are trying, but like she literally can't like get pregnant, like or
Like they're
No.
infertile.
yeah.
Like
Yeah,
That's
yeah.
right.
It's not so much that the length of fertility is longer, it is just much more intense at the time, in that one particular time. But surprisingly, about 80% of difficulty in getting pregnant lies with the men.
80%?
Because you have to remember, a man has to produce 500 or more million sperm to have a chance. So, they used to, I don't have time to go down that road, but they have there's a lot of biasness, because most of the physicians who did this were men, and so they always thought the woman was a problem, but it's usually men. Not having a significant amount of testosterone or production of spermatocytes is probably the major reason why. And so that now they have all sorts of treatments for men to increase testosterone abilities and therefore increase spermatogenesis. Okay, we good?
No.
No? You have more questions?
Yeah.
All right, let me show you real quick. I don't think there's any way. You're gonna know this.
Pictures for the exam.
You're not gonna see anything about this other than, well, maybe. So do you understand menopause? Savannah, what's menopause? Without reading.
It's when they go through stuff. I can't remember.
Okay, what's menopause?
At 51.
Cessation of ovulation.
Passion, I like that. So you basically stop ovulating under the
Yes.
influence of low estrogen levels.
Yes.
Okay. Here it says 45 to 55. It used to be 55 to 65. I think I already had the conversation. But the key with this is that menopause is going to happen. It's like death. So unless a rapture happens before you die, you're going to die. Well, you're going to get into menopause if you live long. The problem with that is how you get into it, go through it, and get onto the other side. You can do it screaming, yelling, and kicking, or you can do it intelligently. What are some of the ways you can actually deal with this? One, regular exercise has been proven to allow menopause to come on slowly. Dietary, obviously, as well as stress. Those three things, if you can control, today's society is kind of hard, but if you can control them, going into menopause and going through menopause cannot be so amazing. And if you really want to know what it feels like, talk to your mom. Because they will share with you what it was like with them, and if you're inquisitive enough, you can ask them, well, what did you do? Did you improve your diet? Did you exercise? Did you do this? A lot of them will go on HRT, which is hormone replacement therapy. That's okay, but you can't control the levels of hormones on a regular basis, so sometimes they're crazy and other times, they're the happiest people in the world. Because the hormone levels are difficult to manage with hormone replacement therapy. All right. And then there are other problems. You can slow down osteoporosis because of exercise, especially weight training. If you do weight training, resistant weights, you can slow down osteoporosis significantly. Hot flashes, if you go into menopause quickly, you're going to have major hot flashes. If you go into it slowly, not so bad. The rest of these, well, you can't do much with this unless you have some kind of cosmetic surgery. That's not an issue, and there are exercises and other things they use nowadays that can actually address that issue as well. So the things you can do. All right, now let me show you what's on the list. So let's see with this one. So let me go through this real quick. So here, you guys ready?
No.
Tell me when you're ready.
Can we turn off the front light?
What?
Can we turn off the front row of lights?
Just please don't.
How's that?
Perfect.
be more than you're going to see, but it's gonna narrow down everything. So you're gonna have this one?
Wait, can you
Can you like
You wanna
click
blow
it?
it up?
Yeah.
Yeah. Blow it